Can AI design a fair future? Some people argue that machines are neutral. So we have an example of the program Compass, which is a software which is able to predict actually if somebody should stay in prison or not, should be bailed out or not. And when we look at this program, we think that neutral, the fact that the machines are neutral is a great thing. But when we look at the scores, we see, for example, this white person having a very low score, while this black person being a very high risk score by the system. There is a big debate saying that actually these algorithms are biased, right? And so maybe, although they are neutral, they may have bias, which is kind of a problem, right? But wait a minute. A lot of us thought like this argument about this white person who looks very criminal, while this other black one is not a criminal, it's not that important. We also have bias. We should not have judged because of that, but we should have looked at the facts. For example, if he has offended or what kind of thing he has done in the past. So not only machines can be biased, but humans too. So the debate is a little bit more complicated than that. So if machines are neutral, but they do bias, what's wrong with them? And actually what is important to understand is not only what's wrong with the machines in general, but what's wrong in the case of AI, in the particular case of AI. And the problem comes from the fact how machine learning works. It works based on learning from a data set. So we have a historical data set where we observe some kind of things, and then the machine tries to create a second program which goes in production, and this second program is called a model, and this model will predict the same way that the data set has been built in the past. So for instance, if we have a person labeled as having done a crime, then this person in the future, another person very similar to this one will have the same prediction, meaning it will commit a crime, right? The problem is that they may be biased in the data sets for the good or the bad reasons, or no reason at all. For instance, engineers tend to be male, and then therefore the machine will learn that males is a feature that discriminates between engineers and not engineers, while this is not true. It's just historically biased. It historically has been this way in the past. So the machine will reproduce this bias, which is a problem. And so some people may think, okay, let's try to fix this in a simple way by just taking out the variable, which is a problem. For example, in the case of learning for the engineer, we will say, okay, let's don't use the attribute, which is the gender attribute, right? And they say, okay, the algorithm cannot see, in some sense, the gender of the person, and therefore will be neutral. But actually this is not true, because machine learning can learn through proxies. He can rebuild and learn using other features or a combination of them. In the example of employment or prediction of engineer, you may look at the hobbies. I mean, if you think about dance, for instance, so dancing is a very feminine, typical feminine hobby, not 100% of the time, but still. And with this proxy, we can still rebuild in an invisible way the proxy. And the problem is also that this will be a very complex model in which you will not see these correlations. So machine learning reproduces biases and tends to build models which are complex and are black boxes which we cannot interpret and we cannot understand and assess if they're neutral or not. Can AI design a better future? Okay, when we see these two big problems, which is interpretability, or the fact that we have black boxes, and the fact that they reproduce bias. And so here I'm going to focus on the particular case that we say, okay, machine learning needs to be black box because of the performance, and can we do something about it? To respond to this question, I'm going to use this very nice example that we use for a research paper, which is trying to learn with some deep learning. We are going to try to learn differentiate the different numbers. Okay, we want to predict that if we show a 0, it's a 0, if it's a number 1, it's a number 1, if it's a 6, and a 6. And here we introduce a bias, which is the color. So all zeros are red, all number 2s are yellow, and number 6 are blue. So can we learn what matters actually means the shape of the color of the number and not its color? Okay, so that's a very interesting thing, and you can see the analogy with trying to learn from predict the employment with and not taking into account, for example, the gender. And so what we do to achieve this is we actually on purpose try to learn the variable which is being here in the problem, the sensitive variable. So what we're going to do is, we add to the historical data. So we have in the historical data, we have the description of the person, then we have the variable we want to predict, meaning if it's a person, we want to predict this is going to be a good engineer, and then we're going to use also the variable if it's a man or a female, a male or a female. And in the case of the colors, of the numbers, we're going to use the color here. Okay, and we're going to still try to learn to predict whatever we want to predict, if it's bailout or not bailout, or if it's employment or not employment. But we're going to also try to learn what is producing or what is detecting the bias. Okay, and this is, for example, what I call in this schema, we're going to have an algorithm which is going to punish the learning. Okay, so we're having something that is called adversarial learning. At the same time, we are going to learn whatever we want to predict, and we're going to try to, at the same time, not to unlearn, we're going to try to unlearn the bias, okay? And this, at the end of the day, we're going to finish up with a very complex model that will learn the risk, but not will learn the sensitive variable, and will be completely unsensitive. And so it looks like very simple in this schema. I wanted to show you how it looks like under the hood. So I took the schema of one of my papers, the recent papers. If you want to have a little bit more details about this, you can check it on the website that you see on the screen. And under the hood, this is exactly what we do. We have a path, which you see here, X to Z, and from Z we go to Y hat. And this is the reward path. So we're trying to, from X, predict Y. And at the same time, we have another path which goes from S and back to Z and then to Y, where we completely punish with the sensitive variable, and we try to take out the bias. So this is basically how we're trying to do this. And how do we test? Can we see if these things work or not? Well, actually, we took the same type, so we have this training data set, and now in order to test it, what we did is we took the colors and we did the numbers, and now randomly we put randomly we put colors. So in other words, if the algorithm learn the colors instead of learning the shapes, it will have a very bad performance, because now we are on purpose making the information about the color irrelevant. Okay, and on the right you can see if we have we compare what we did with traditional algorithms, and you see that traditional algorithms tend to learn actually the bias, because actually the bias is very predictive. But by doing this adversarial thing, we are able to predict with a quite high accuracy the right thing. So we are able to predict the numbers without having any bias. We are able to predict with taking what matters and not what is irrelevant for the purpose. So this is very mathematical, but I think there are high consequences, there are big consequences for the society. So if we think about it a little bit for a second, we realize that there are consequences for our society. Actually, if we look at our algorithm, we are forced to introduce the sensitive variable. It means that anybody who would like to do a fair machine learning has to have access to the sensitive variable. So if you think this is religion, and you are sharing this with maybe healthcare, or maybe you're sharing this with insurance or a bank, this means that you have to share this information. And this may have this creates a big questions. But I still believe that this is the way forward. This is the way that we need to share the variable, because it's the only way we are able to understand if we are having a bias or we are discriminating or not. And this is a big change for us. I mean, some countries have some sort of degree of tracking of their sensitive variables, but in Europe, for historical reasons, we don't. So I think we believe, and I believe that we should promote active fairness, meaning using in an active manner these variables to promote fairness. And I just put this image because I think it's very important, is that justice for centuries has been blindfolded. We have put it's blindfolded because we want to say that she has not to look at the people based on their features and not be biased. But I think in the case of AI, which is different than human intelligence, we need to provide this information to make a much more fair world. A second consequence of this research, mathematical research, which I think is extremely interesting, is that we are actually asking ourselves, what does it mean to be fair or not to be fair? And not just in a philosophical matter, but in some point in this algorithm, in these equations I show you, we're optimizing something. And the thing that we're optimizing is the definition, is the written definition, precise definition of what fair means. And this is a very complicated problem, because actually there are a lot of things that can be considered as fair. And this is why there are a lot of definitions which have appeared. And you see in the image, there is group fairness, statistical parity, there is equalized odd, there is calibration issues, there is a lot of features, there is a lot of measures and ways to measure, to define what fairness means. And some of them are not even compatible. Again, if you're interested in the topic, you can have a look at our GitHub. So I think this is the debate today. I think there is mathematical and machine learning are a big opportunity to have a much fairer world. Yes, AI can help us to design a better future, but as I said in the presentation, we will need to trust humans, because we will need to share with them the sensitive variables, and we will also need the human and the society to be able to translate what fairness means in a more mathematical way.